In this lesson, we're going to look at how the discriminant can tell us certain things about the solutions to quadratic equations. So firstly, the discriminant is the part of the formula that is under the radical in your quadratic formula equation. So our discriminant is, oh, and I need my pen. Our discriminant is just b squared minus 4ac. And so what we will find is that the value of this discriminant, whatever b squared minus 4ac simplifies to, will tell us how many roots our quadratic equation will have when it graphs. So the discriminant will determine if there are 2, 1, or no roots. If your b squared minus 4ac reduces to or simplifies to a positive number, then that's normal. That means you're going to have 2 answers or 2 roots. That means you've got a quadratic or parabola that's crossing your x-axis at 2 points. That's normal. It can be up or down, but it's crossing your x-axis in 2 places. If the answer to your discriminant is 0, meaning when you get whatever simplifies under the radical, when you get that, it's 0, then that actually means that there's only one answer or one solution, one root. That's a scenario where your parabola is crossing the x-axis at its vertex. So that's the only time it hits your x-axis is just once. So this should make sense because if whatever your b is here, negative b over 2a, whatever those numbers are, if you add 0 to the top, it's going to still just be negative b up top. And if you subtract 0 from the negative b, it's still just negative b up top. So you're getting the same number when you do the plus or the minus. So that's why it's just one number that represents your solution. Finally, the final scenario is, let's say your discriminant simplifies to a negative number. This is an example where your quadratic has no answers or no roots, no solutions. And what this represents is a parabola that never hits the x-axis. It never crosses it, never touches it. So that could look like a parabola opening up or down, but just never coming to that x-axis. So depending on the value of your discriminant, you can very quickly identify the kind of quadratic or the kind of parabola graph you're dealing with. So let's start by taking a look at the finding some discriminants and just determining how many roots would this quadratic equation have. So here's our first example. We have 8x squared minus 9x minus 5 equal to 4 minus 3x. Step 1 is the same step 1 we've been dealing with all unit, where we need to begin by setting our equations equal to 0 by bringing those things to the other side. Once we've done that, and I'll need my selecting tool here, we will then find the discriminant. So for your discriminant, you're just worrying about b squared minus 4ac. So here a is 8, b is negative 6, c is negative 9. And so the discriminant in this scenario will be found by doing negative 6 squared minus 4 times 4ac, 8 times negative 9, and all of this simplifies to 324. So that means the chunk, as I like to call it, that's under the radical for the negative b plus or minus square root of b squared minus 4ac piece. I don't know what that's doing there. Okay, that piece is positive. So that tells you very quickly that there will be 2 roots for this quadratic equation. 2 roots. From there, you might go and find whatever piece of information you need for whatever you're trying to do with the quadratic, but this is just a really quick way to see. This will have 2 roots, and you will be able to find them. Okay, here's our next example. So we have 2x squared plus 10x plus 11 equals 0. Step 1 is to set it equal to 0. That is already done for us. Step 2 is to find your discriminant. So before you find your discriminant, remember to jot down what a, b, and c equal. So A is 2, B is 10, C is 11. I'm going to give you a moment to find the discriminant by substituting those values into b squared minus 4ac, and then let's check it together. So just take a moment to do that. Okay, so substituting 2 in for A, 10 in for B, C as 11, we should simplify to a discriminant of 12, which is positive. So because it's positive, again, this is an example of a quadratic equation that will have two roots. It's opening up, so really quickly, you know, in some way, we've got an opening up graph crossing the x-axis in two places. All right, here's your next example. Start by setting this one equal to 0, then find your discriminant. When you're ready to check, we will come back together. So hit pause and then click play when you're ready to check this. Okay, so setting equal to 0 should have looked like this, and your discriminant should have been -8. This is an example of a no real roots solution. So this tells you that the graph of this quadratic would never cross your x-axis. And so if you're in this situation, then to graph it, you would need to find your vertex, and then you would need to set up a table of x and y values and just plot all those points to be able to graph it. But here our A is positive, so that tells you in some way I've got a parabola opening up but never hitting the x-axis. Here's another one for you to try. So go ahead and set equal to 0, which is done for you, and find your discriminant. Click pause when you're ready to check. Click play. All right, so it is set equal to 0. Your discriminant should have been 0 in this case. So that tells you that this is a quadratic equation with only one root, meaning that the one root that you find is also considered your vertex. So because A is positive, this will open up, and that one root lands on the x-axis as your vertex. And so that's really the end of our lesson on how the discriminant is going to be useful to us with determining number of roots. The last thing I quickly wanted to talk about was a problem you'll see on homework. This problem says that a boy throws a baseball into the air. So if I'm thinking about this scenario, I've got a boy, this is a horrible picture, throwing a ball into the air. And this is probably better here. So he's standing on the ground, right, and he's throwing the ball into the air. Its height, h, in feet at time t in seconds is given by the formula h equals -16t squared plus 29t plus 6. And we're wondering at what height was the baseball released from the boy's hand? So when you're looking at this, he's going to throw this ball, and it's going to go up in the air, and then it might get caught or it will land on the ground, right? But somehow it's following this trajectory. What I want you to notice is that the point it's leaving the boy's hand, or in my example here, the man's hand, is above the ground. So while a parabola like this would have a root over here on the ground, that's not what we're concerned with. What we're looking for is where's this ball leaving the boy's hand? So at what height? And that height is above the ground. So we have to figure out what is this height here above the ground. And when you're looking at a problem like this, you have to think about, in this scenario, when does the time start? And the time is going to start when he releases this ball. So if the time is starting when he right at the moment he releases, then that means that this point here has a time of 0 seconds. So with this equation, you would replace t with 0 because we're really looking for at 0 seconds, when does the ball leave his hands? What's that height? So we're looking for height when the time is 0, and you would solve, and 0 times all this plus 0 times that plus 6 tells you that the height is 6 feet. In this case, they told us it was feet, right? Yep, feet. Okay. So a quicker way to do this is to think about your starting point always being your C value. And while there is another root down here, there would be two roots to the graph of this parabola. The starting point represents the height at which this ball left, which is actually also just whatever value your C is in your quadratic equation. So I just wanted to go over that real quickly with you to start looking at C as thinking about it as your starting point in these graphs. And that's all we have for today.